Welcome back, everyone. This is Dr. Gallenstein, and today we are going to do another lecture on conducting economic experiments to evaluate the impact of development programs. Today we're going to talk about doing RCTs in practice. So just a couple points related to the practical implementation of RCTs, as well as one tool that we can use when we're not able to conduct an RCT. Okay. Let's jump right in. Now, when we talk about RCTs, kind of the best case scenario is if we're able to do a pure experiment RCT. And what do I mean by that? I mean that you have some big grant to conduct a research project, and so that you don't even need to work with an institutional partner, or if you did work with an institutional partner, that you could fund the whole program, and so you could have the institutional partner implement the program in exactly the way you want to give it to the people that you want them to give it to, and do it in the timing and the place that you prescribe, because you have a big grant, and so you can fund all of the activities of the intervention and the program. In fact, if you have a big enough grant, you can create the intervention yourself and then implement the intervention yourself. When you do that, you have full control over the implementation of your RCT, and you can create the intervention, randomly implement the intervention, evaluate the intervention, and then make policy recommendations based on your results. Now that is, from a researcher's perspective, the best case scenario, because you have the most amount of control over the implementation of your intervention. And so you can kind of do a perfectly designed intervention. Now, the problem is that it's not very common that you can do a pure experiment. And the reason why I say that is because it's pretty uncommon that we have large enough grants that we can design our own interventions, and we can introduce those interventions in exactly the way that we want to, in the time frame that we want to the people that we want to give it to. Okay, so we oftentimes will be working with institutional partners. What do I mean by that? When we do impact evaluations of development programs, typically we have a partnership with some organization that is implementing some intervention. So this might be a nonprofit organization, or it might be a government organization, or it might be some international development or international aid organization. And when we work with these partners, they have their own goals and objectives that they want to meet. They might not be perfectly flexible when it comes to conducting research. They want an impact evaluation, but they have other objectives as well. And so they can't necessarily follow the perfect experimental design that you would want it to be. So in that context, we need to think about just some practical ways in which we might introduce randomization into the implementation of their program so that we can do an RCT. So we're just going to talk about a couple options. Okay, so another example would be a random phase-in. All right, so what is that? So let's say that you're working with some institutional partner, and they've developed some intervention. So we'll just use our go-to example. Let's say we're working with a nonprofit organization, a development organization. I'm just going to say World Vision. It's one I've had interactions with in the past. And they want to provide fertilizer subsidies to farmers. Okay, so they have a program. They already have plans to implement it. Okay, and right before they implement it, they contact you and they say, "Well, we want to do an impact evaluation of this program." Now, if you're able to communicate with them before they begin rolling out their program, you can use a random phase-in design. All right, now what's a random phase-in? So let's say we're working with World Vision, and they are implementing their fertilizer subsidy program. And they want to reach a population of 100,000 farmers with their fertilizer subsidy program, but they don't have the resources to provide the subsidy vouchers to all 100,000 farmers in the first year. So they plan on giving it to 50,000 farmers in the first year, and then the second year they will upscale and give it to all 100,000. So in this case, the NGO is phasing in their intervention. They're not giving all of their target population the intervention at once. They're phasing it in. Well, if you have an institutional partner that is phasing in their intervention, then what you can do is try to randomly phase it in. So you work with your institutional partner and you say, okay, you're going to phase it in. You're not going to give it to all 100,000 farmers in the first year. Well, let me come in. Let me randomly decide who the first 50,000 is. I'll randomly assign farmers, 50,000 of them, to get the intervention in the first year. And then you can give the fertilizer to all 100,000 in the next year. So you're still phasing it in, just like you planned to do it before, but just let me randomly determine the first 50,000 instead of you determining the first 50,000 in whatever means that you are going to. Okay, so in this case, what we're doing is we're randomly determining who receives the first phase, knowing that the rest will receive it in the second phase. Okay, so that is a random phase-in. That is a common possibility when you're implementing RCTs in practice because, like I said before, you oftentimes don't have full control over the intervention. So you have to work with your institutional partner to see whether or not they can randomly phase in their program. Okay, now the drawbacks of this, there can be some drawbacks. When we're doing an impact evaluation and we do a random phase-in design, one problem is the timing of the phases. So let's just imagine we're doing a random phase-in design. So that means we're randomly determining who gets the first phase of the intervention, knowing that everyone will get the intervention in the second phase. All right. If the second phase comes too soon after the first phase, then it might be impossible to identify an effect. What do I mean by that? What we do when we're doing a random phase-in design is that we use the first phase as the treatment group, and the second phase, that means everyone else, everyone who's not included in the first phase, everyone else is the control group. So that means we have 50,000. So World Vision wants to give their program to 100,000 farmers, but they're only going to give 50,000 in the first year. So we randomly pick the 50,000 that get it in the first year. So that means at the end of the first year, we have the 50,000 that got the intervention and the 50,000 that didn't. So we have a treatment group and we have a control group. And so what we'll do is we'll compare the 50,000 that received it, the treatment group, to the 50,000 that didn't, the control group, and we will use that to determine the impact of the intervention. Okay, so that's our treatment group and our control group. But here's the problem. That intervention needs time to take effect. It needs time to influence farmers' behavior and their outcomes. If the second phase comes into place too soon after the first, there's not going to be enough time for the first phase to have an impact that we would be able to measure. So let me illustrate this problem. So what I'm saying is in the phase-in, the random phase-in design, we have some population of, let's say, 100,000 farmers. And we're asking World Vision to let us randomly assign these 100,000 to two groups. One has 50,000, the other has 50,000. All right. This first group, and we're randomly doing it, so random. All right. This will be our treatment, and this will be our control. All right. So now what we're saying is that this treatment group, all right, I'm going to draw a timeline here. So we've broken our 100,000 into two 50,000 groups, and we are going to give the intervention to the treatment group, and we're not going to give it to the control group. But now let's think about this, okay? Let's say this is taking place in 2019. We're giving the fertilizer in 2019. All right, so the treatment group receives the intervention in 2019. So they have it all the way through. The control group is going to receive the intervention in 2020. They don't have it in 2019. All right, now here's the problem. If that intervention comes too soon for us to be able to observe an effect, then the random phase-in is not going to work in terms of allowing us to identify the true impact of the intervention. So let's just illustrate this. So we're going to say that the intervention takes place here, and so the treatment group gets it, the control group doesn't. And then we're going to collect data here. We're going to collect our data here. So at this moment in time, we will compare the treatment group to the control group. All right, the treatment group has had the intervention. The control group has not had the intervention. Okay, now what I'm saying is this amount of time, the time between the intervention being implemented and the time at which we're measuring, needs to be big enough to see an impact. All right, let me clarify that. The amount of time between the time of the intervention and the time when we measure, the time that we collect our data, there needs to be enough time for the intervention to have an effect. There needs to be enough time for that intervention to take effect, to influence the outcome variable. If there's not enough time, this is going to be a problem, because if there's not enough time between the first intervention and the second intervention that takes place here with the rest of the people, if there's not enough time, then when we do this comparison, when we compare the treatment group to the control group, there will be no effect. We won't be able to observe an effect because the intervention has not been able to take effect yet. It hasn't had enough time to influence the outcomes. And then we can't measure it afterwards, because if we were to try to measure it afterwards, if we were to try to measure it later, then the control group would have the intervention, and then we wouldn't get a clean observation of the effect. So the phase-in can be a nice design, but the second phase has to be implemented far enough after the first phase to give the intervention time to take effect. Another drawback is expectations. So in the phase-in design, what we expect to do is to compare the treatment group, those that receive it in the first phase, with the control group, those that receive it in the second phase, and we compare them before the second phase people, the control group, receive the intervention. Okay. And what we expect is to find differences in outcome between those that receive the intervention and those that don't. But here's the problem. If the control group knows that they're going to receive the intervention next year or in the next phase, they might change their behavior relative to those who would never receive the intervention at all. And if they change their behavior, it will create a bias. This is basically a form of randomization bias. Okay, so that's random phase-in. Another option, the oversubscription method. So with the oversubscription method, this is another way in which we try to introduce randomization when we don't have full control over the implementation of the intervention. Okay, so let's imagine a scenario in which we're working with a nonprofit organization. They have already implemented an intervention. So they are already providing their intervention. Well, how are you going to do an impact assessment if the intervention has already been implemented? It's not obvious who your control group would be. They're already implementing the program. Okay, well, how can we do that? How can we do an impact assessment in that context? All right, well, when there is an existing program that has excess demand, that means there are more people that want the intervention than there are spaces for the intervention. So let's just take an example of a microfinance program. So let's say World Vision is implementing a microfinance program. World Vision has their own separate organization for that called their own separate organization called Vision Fund, their own subsidiary, microfinance subsidiary, Vision Fund. So let's say Vision Fund is providing a microfinance program. Okay, but they can only offer, let's say this regional office of Vision Fund can only offer 10 loans a year, but they have 30 people that want to get microfinance loans, or 30 groups that want to get microfinance loans. So this microfinance program is already in place. It already exists. We want to assess the impact of it. But the program isn't new, so we can't randomly assign who gets it at first. But we recognize something about it. We recognize that there's excess demand for this intervention. There are all these other groups that want to be able to access these loans. Okay, so what we can do with an oversubscription method is we recognize that there's this excess demand, and we work with our institutional partner to see whether or not they're willing to expand access to their program to some of those who have demand for the program. Okay, so that is, we work with the institutional partner to see if they're able to increase the scope of their intervention. That means add additional people who demand their intervention to the program. Okay. And then before that happens, what we do is we identify a sample of eligible participants that do not have the intervention, and we randomly assign them to receive, some of them to receive the intervention and others not. And so what we do is we create a little, we create an RCT with that population, the population that would like the intervention, and we work with our institutional partners to expand access to their intervention to our randomly chosen individuals that would like access to the intervention. Okay, so what this does is it allows us to evaluate the impact of the intervention on this marginal population. Marginal meaning the population that is on the margin of being able to access the intervention. Okay, and this is called an oversubscription method. All right, the next one, an encouragement design. Now, sometimes you're working with an institutional partner, or you are working on evaluating the impact of an intervention, and that intervention is such that you cannot restrict or control access to the intervention. So let's say, you cannot restrict access to the intervention, but utilization of the intervention is not universal. So let's say that you wanted to assess the impact of having, you want to assess the impact of having a mobile phone on welfare outcomes of rural households in Tanzania. Okay, in the past 10 years, cell phone access has expanded rapidly in countries in the developing world, so that includes Tanzania. So if you go into a rural village in Tanzania, you'll find many people that have cell phones. All right, so here's a good example. You can't restrict access to people having cell phones. Now, you could design an RCT where you go in and you give some people cell phones and some people not cell phones, but even the people that you don't give cell phones to, they still have access to cell phones. You can't restrict who can access and who cannot access cell phones. Okay. But utilization of cell phones is not universal. All right. In that context, you can utilize an implementation method called an encouragement design. All right, so an encouragement design will be a situation in which you randomly assign individuals to receive some sort of encouragement to use an intervention or to avail themselves of some universally accessible program or intervention. Okay, so in the example of cell phones, you can't restrict whether or not people have access to cell phones, but you can introduce some sort of encouragement design, some sort of encouragement where, let's say, you randomly provide households with the vouchers that they use to get minutes on their cell phone. So you randomly assign people to receive minutes for their cell phone network and others to not. Now you've just provided a randomly assigned intervention that will increase the likelihood of your treatment group using cell phones relative to the control group. And so you can use that intervention to try to elicit the impact of having a cell phone. You can't restrict access to the cell phone, but you can provide something else as an intervention that will substantially increase the likelihood of your treatment group utilizing whatever that program is. Okay, another example. Imagine the government made fertilizer vouchers, so subsidized fertilizer, openly accessible. Anyone can go and get a voucher. So access is not restricted. Anyone can go and get a voucher to buy subsidized fertilizer. And so you can't restrict access to the fertilizer. You can't randomly assign who gets the fertilizer and who doesn't. But utilization is not universal. That means not everyone is availing themselves of this fertilizer subsidy. So what you can do is you could randomly assign people to receive some sort of encouragement, something to help them take advantage of this accessible program. So instead, let's say we randomly assign households to receive an in-person invitation to make use of the voucher. Or you do an in-person invitation, or you provide them with some added ability to access the voucher, like some transportation to the market where they can pick up the voucher. Or you deliver the voucher to them. It doesn't change their access to it, but it makes it easier for them to avail themselves of the intervention. Okay, so then your treatment group would be the people that received this encouragement, something that helps them take advantage of the program. So the people in your treatment group will now be much more likely to receive the treatment than the people in the control group. And then you can utilize that to identify the impact of the program itself. So you want to measure the impact of fertilizer, but everyone has access to the subsidies. Well, what you do is you can randomly assign something that would help them take advantage of the subsidy. And therefore, that you can use that to try to assess the impact of the fertilizer subsidy. Okay, we'll go more into detail on that later in the class. We'll learn exactly how to conduct that type of analysis. What you would do, just to give you a primer, is you use that invitation as an instrumental variable to identify the treatment effect of the fertilizer voucher. But we'll get more to that later. Okay. All right, now, what happens if we can't do an RCT? And by that I mean we can't even randomize. What do we do if we can't even randomize? All right, so I just went through a couple of examples, practical examples of you're working with some sort of institution and you don't have the ability to perfectly control the intervention. And so what you do is you try to sneak some randomization in there somehow. You sneak it into the phase-in process, or you use oversubscription, or you randomly assign some encouragement. Okay, so you're working with an intervention. You can't just randomly implement the intervention in the way that you would like, and so you have to sneak some randomness in there somehow. Well, what happens if we can't even do that? We can't even sneak some randomization in there. What can we do? Well, and this happens often. You will be asked to do an impact assessment on a program for which you have no ability to introduce randomization. Well, in that case, we have to use some other techniques. Now, later in the class, we'll learn some empirical techniques, some econometric techniques. But right now, I just want to introduce one idea that you will see while you're going through our master's program. Without a doubt, you will see this, and so it's an important tool to have in your toolbox. All right. So it is common that we do not have the luxury of being able to conduct an RCT. That is, we don't have the luxury of randomization. But you may be hired to evaluate a program that cannot or will not randomly assign people to receive their intervention. So in that case, we need to be creative to try to create a valid control group, as valid of a control group as you can find, as valid of a counterfactual as you can find. Like I said, we have a number of different tools in our toolbox. Many of them we'll address later in the class. I want to look at one here today. So in this case, we can try to construct a valid control group or a good control group. So one thing that we can do is we can use data or we can use local knowledge to try to find as comparable of a population as you can to your treatment group. I'm not going to emphasize this one. This one's very hard to do. Now, in practice, should you do the best job you can? Absolutely. And then you can take this and combine with some of the methods that we talk about later in the class. So I'm not going to emphasize this first one now. What I want to do is I want to look at the second one. All right. And what am I looking at here? I'm saying I'm going to call this taking advantage of self-selection. All right. So if the intervention has some self-selection mechanism that determines participation in the program or the intervention, sometimes we can take advantage of that to identify a control group. Or we can take advantage of that self-selection process to reduce the amount of selection bias that we have. All right, so let me describe that. Let me describe what I mean by taking advantage of self-selection. And let me give you an example from a program. So we're going to call this, we're going to just take an advantage of we're going to use the example of an educational program. So let's say you've been hired to evaluate the impact of some educational program. Let's say it's a program in which schools are introducing computers into the classroom. Okay, we're just going to use that as an example. So you want to evaluate the impact of this program. And actually, let me think of a different one. We are evaluating the impact of some computer training program. Yeah, this is better. Some computer training program. All right. You can't randomly assign people to participate in the computer training program because the program is purely voluntary. People choose whether or not they participate in it or not. All right. Now, in this case, your treatment group obviously is going to be people that have participated, have received this computer training program, people that have voluntarily and willingly participated in this computer training program. All right. So the treatment group is those that receive the computer training program. Well, who will the control group be? Now, keep in mind, in this case, there's a self-selection. People are self-selecting into receiving this computer training program. So we know that there will be self-selection bias, right? We know that if we compared the people that received the training program to people that didn't, that there would be a self-selection bias. There's some reason why those people availed themselves of the training program and the ones that did not, did not. All right, so that's a self-selection problem. And that arises because people can choose to enroll in the program or not. And whatever causes people to choose to enroll in the program is going to make them different from the general population. And so it'll be difficult to identify a valid control group because of the selection process. There's something that makes this treatment group different, or some group of things, some collection of things that makes them enroll and others not. That's the self-selection process. Now, sometimes we can take advantage of that self-selection process to identify a control group. How can that be? So the primary source of bias is self-selection. All right, so we can try to control for the selection bias if we could identify another group of people that also self-selects into the program. Okay, so right now we're talking about a computer training program. People choose to participate in the program or not. Now, if we are creative, we can try to identify a control group that is also self-selecting into the program. Okay, so we can identify a population that is also self-selecting into the program. Now, just as a quick side note, if you are able to do some randomization, here's some idea. Here's an idea. Let's say we have this computer education program, and they open enrollment, okay, and they have 100 applicants that are accepted to the program. Well, you could do a random phase-in where you randomly assign 50 of them to receive the computer training program this year and the other 50 next year. That would be a randomized phase-in design. All right, in which case the entire population has self-selected into the program. Okay, but now let's say we can't. Again, we can't randomize. So, but let's think about this. We have this computer training program, where some group of people have self-selected into participating in the computer training program. Now, we can take advantage of the self-selection process to try to identify a control group. Let's think about it. Typically, educational programs are programs that are offered on some repeated basis. Maybe it's every year or it's every semester. And the admissions process is completed for students before they begin the education. Okay, so the selection process occurs before the intervention is received, right? There's some application program. You have to apply, you have to get accepted, and then after you're accepted, sometime later you enroll, and then you receive the training program. Okay, so there's some time. It takes time between the time at which the selection occurs. The selection occurs through the application and approval process. So the process between application and when you get accepted into the program. Okay, that's the selection process happens there, but then the intervention takes place later. We can take advantage of that. We can take advantage of the fact that this educational program takes place repetitively to try to identify a control group. This control group would be a group of people that also self-select into the program. All right. Now, this is not a perfect method, but it helps us to reduce the amount of bias because it helps us to control for that self-selection process. Now, let me give you an example of what this would look like. All right. Here I have a timeline. All right, and let's just say I have a timeline from 2018 to 2020. All right, we're taking advantage of self-selection. So let's say the acceptance process happens early in 2018, and enrollment happens in late 2018, and then it happens again for another class of people in early 2019, and then the enrollment occurs in late 2019. Okay, so with this type of repetitive process, we can try to take advantage of the self-selection process to create a treatment and control group. So let's say we have two groups of people, group 1 and group 2. Now, group 1 is the group of people that applied and were accepted to the program in 2018. Okay, so now in this time between acceptance and enrollment, they have been accepted. So they have gone through all of the process that selects them into the program. The self-selection that is choosing to apply, and the acceptance process of the educational program that chooses them. So by this point, middle of 2018, Group 1 has been selected. They're going to participate in the program, but they haven't received the intervention yet. They haven't received the computer training program. Then after enrollment, then they receive the intervention. Okay. Group 2 is the group of people that apply for the subsequent year. They're accepted in early 2019, and then they enroll in late 2019. Okay, so we have two groups of people, and look at this, two groups of people, and both of them have been self-selected. Both of them have self-selected into the program. So they do not differ with respect to the self-selection. They both self-select, but they are different. You'll notice that Group 1 receives the intervention before Group 2. So let's say that we collect data, we do a survey at this moment in time, right around enrollment of 2019. At this moment of time, Group 1 has received training for a year at this point, and Group 2 has not received the training. But both Group 1 and Group 2 have both gone through the self-selection process. They're both self-selected into the program. And so we might think that comparing Group 1 at this moment in time to Group 2 at this moment in time would give us at least a really good treatment and control group. So what we would do is we would say Group 1 is the treatment group. We collect data at this moment in time. And then Group 2 is the control group. We collect data at this moment in time. And then we compare them. We compare this treatment group to this control group. And we look for the impact of the training program. They both self-selected, so we don't have that self-selection bias. Now, maybe there's some other differences. There's some reason why these people applied in year 2 that they didn't apply in year 1. So there still might be some differences. It's not perfect, but it goes a long way to helping to reduce that bias. Okay, thank you so much. Really pay attention to this last topic. Almost certainly you will see it in your applied impact assessment work, so make sure that you take careful attention to this. And with that said, I'll see you in class, and we'll keep digging in. We'll keep learning how to design and implement these experiments. I hope you have a great day.